Resource monitoring. Alright, in this module we're going to talk about the different tools and the different ways that ESX Server allows us to monitor the resources available to the virtual machines and the resources available to the hosts. Regardless of how great a particular system is and no matter how good you build it or architect it, if you don't have good monitoring in order for you to be proactive about trying to find potential problems and fixing them rather than being reactive to problems, you're always going to be faced with challenges. So in this module we're going to try to cover all the basics, all the things that ESX Server and Virtual Center give you out of the box in order for you to monitor your resources. So the topics that we're going to be covering here, we're going to be talking about CPU and memory concepts, how the different CPU or how the VM kernel and ESX in general manage CPU and memory optimization and concepts. We're also going to be talking about performance monitoring using Virtual Center and some of the tools that are available to you, and we're also going to talk about being able to work with alarms, and alarms are basically values that you set on certain resources so that if these values are broken, a certain alarm is set and triggered, and that way you'll be able to see it and know, okay, there's a problem here. Maybe memory utilization has spiked or CPU utilization has been running at 100% for a while. Stuff that will pinpoint you in the right direction for you to be able to take action against these resources, and either to lower them or to add more resources in order to make sure that your virtual machines are running in an optimal state. So let's dig into the CPU and memory concepts and take a look at how the VM kernel automatically manages these resources in an optimal way, and the different techniques that are available to the CPU and memory concepts within ESX. With regards to CPU, we're going to be talking about load balancing, how the VM kernel load balances the load of all the VM or the vCPU's requests for time on the physical CPUs. So how it manages the vCPU's requests on physical CPUs. We're also going to be talking about how the VM kernel takes advantage of hyperthreading. Then we're going to move on to memory and take a look at some of the concepts and some of the tricks and tweaks that the VM kernel uses in order to make sure that it has the memory it needs and that it's not running out of memory. And obviously all of these come into play when the resources are scarce and the VM kernel needs to shuffle things around in order to make sure that the necessary resources are available for the necessary or for the requested virtual machines. So we're going to talk about the transparent memory page sharing. We're also going to be talking about the VMmem CTL driver, or in other words, it's called ballooning, and we're going to get into detail about that. And we're also going to be talking about the VM kernel swap file, which I'm sure you guys are familiar with the concept of a swap file, but we're going to get into detail about that as well. So let's kick it off with the CPU load balancing. So you have a virtual machine that has one vCPU. That one vCPU is scheduled on one physical processor. If you have a virtual machine that has two vCPUs, then each one of those two vCPUs has to be scheduled on two physical CPUs. If you have a virtual machine with four, obviously it would have to be scheduled, those four vCPUs would have to be scheduled on four physical processors. So what happens here is every 20 milliseconds, the VM kernel is going to go around the physical CPUs, take a look at the load on these physical CPUs, and if it notices that there's a lot of load on one physical CPU and there's not a lot of load on the other one, it's going to shuffle those virtual CPUs between the physical CPUs in a way that would make sense and would free up resources or would lessen the strain that you have on a physical CPU. So every 20 milliseconds, it's going to take kind of like an inventory of the physical CPUs, see which one is being choked or which one is being crunched, and it's going to move virtual CPUs off of that and assign it to other physical CPUs in order to relax the load on a particular physical CPU. The service console is always scheduled on CPU 0, on physical CPU 0. The service console is not one of those CPUs that the VM kernel can move to another physical CPU. It always has to run on pCPU 0. Now a question that I'm always asked is, what happens if we lose one physical CPU? Well, the answer is simple. If you lose one physical CPU, the system's going to crash. The reason being is the VM kernel always expects to be running on functioning hardware. So the loss of one physical CPU will crash the system. So this has to be clear. All right, let's move on to hyperthreading now. Let's bring up the slide for hyperthreading and talk a little bit about hyperthreading. So does hyperthreading actually double the processing power of a CPU? The answer is no. What hyperthreading does is it allows two threads to execute on a single physical CPU. So it's not doubling the capacity, it's just allowing two threads to execute on one physical CPU. Now, from an operating system standpoint, and I'm sure you guys have seen this many times with Windows 2000 and Windows 2003, etc. When Windows loads, Windows is going to see the CPUs as two. So if you have one physical CPU that's hyperthreaded, the guest operating system is actually going to see it as two logical CPUs. Hence the drawing here. I have one physical CPU which translates into two logical CPUs. Now, ESX takes advantage of this technology, which allows ESX to schedule virtual CPUs to run on logical CPUs. Now, the VM kernel is also smart enough to notice that if you have two virtual CPUs that are each connected to the same, or to two logical CPUs that are on the same physical CPU that are on one CPU core, if these two vCPUs are CPU intensive, it is smart enough to know that they're running on the same core. As such, it will move one of them, it will move one of the virtual CPUs off of the logical CPU onto another logical CPU that is on another physical core, so on another physical CPU. I'm saying the word CPU a lot here, I know, but there's no way around it. So if you have two virtual machines, each with one CPU, and those two virtual machines are scheduled on a CPU 0, for example, and CPU 0 has two logical CPUs. If one of those virtual machines, or if both of those virtual machines are CPU intensive, what the VM kernel will do is it will move one of the VM's vCPU and schedule it on another logical CPU that resides on physical CPU 1, for example. That way it will release the load off of the logical CPU on pCPU 0. It's really cool to see how ESX really is taking advantage of a lot of the technologies and is making them, is pushing the CPU to work to the max. You're noticing here how a virtual CPU can now be scheduled on a logical CPU, so you can't double the capacity of the CPU, but technically you're kind of tricking it because there's two threads of execution. It's kind of working as if it were two CPUs, but it's not. And at the same time, it is smart enough to know that if there's a lot of load on the logical CPUs, it can move them. It'll know that this is a logical CPU, it's not a physical CPU. This is really cool stuff. VMware has really taken the technology one step further and is being able to exploit every little bit of the processor or the CPU to maximize on performance. Alright, now let's turn our attention a little bit to memory. Let's bring up the slide here for the transparent memory page sharing. And this is really cool technology here. Again, I can't stress enough, I'm not trying to market VMware here, but the technology is so smart and it's so intuitive that it kind of forces you to just be amazed by the amount of thought that went into this to be able to deliver such smart technology to us. Now, the concept of transparent memory page sharing, what is it? What's its advantage? So you have virtual machines here that have virtual RAM, virtual memory. Now, these virtual machines have, like, let's say for example, you've assigned this virtual machine 1 gig, and this virtual machine 1 gig, and this virtual machine 1 gig, 1 gig. All of this obviously 1 gig of RAM. Now, this 1 gig of RAM is obviously 1 gig of virtual RAM that needs a chunk of the physical RAM in order to be allocated to those virtual machines. Now, what the VM kernel does is it detects when these virtual machines have identical memory pages. So let's say you have 4 Windows 2000 boxes here, and those 4 Windows 2000 boxes have identical memory that they're using in order to function properly. So what the transparent memory page sharing does is instead of allocating a chunk of the physical RAM to all of these virtual machines, which are running, for example, the same processes, and they're running them just for read-only purposes. They're not doing anything to them. Instead of allocating 5 or 4 pieces of the same memory, what it does is it allocates 1 piece of the same memory and then lets those 4 virtual machines attach to this 1 piece and use it. Now, let me make this a little clearer and give you a different example. You have an Excel spreadsheet on a file server somewhere. This Excel spreadsheet is in read-only format. Okay? And you have 5 users that are managers that need to open this Excel spreadsheet on the file server. So what do? Do you make 5 copies of the Excel spreadsheet and put it on the file server in different locations and then tell them where it is? Or do you have one file which is read-only, and then you tell them, okay, the file that you're looking for is here, and you can open it, and you have only one version of the file? Now, obviously, this makes more sense. So you have one version of the file. It's in read-only. All 5 managers can open this file and read it. Now, if they want to make modifications to this file, what they do is they make a copy of it, either download it to their workstation or put it somewhere else on a file server, open it, modify it, edit it, save it. It becomes their private copy. The same thing goes with the transparent memory page sharing. As long as these virtual machines are accessing memory pages that are sort of in read-only, the memory pages that aren't being modified or changed, they're accessing 1 copy of this memory that's on the physical RAM. Once a virtual machine needs to make a modification to these pages, needs to write to these pages, what happens is the VM kernel will make a copy. It will copy this chunk that was used that was being shared between all of them. It will make a copy of it and make it into a private copy, and then let the virtual machine make all the changes it needs to it on an individual basis that is not shared with anyone else. The same concept as with the Excel spreadsheet here. When somebody needs to make a modification to it, they make a copy and they use their copy. Again, here, the VM kernel will make a copy of that shared memory space, and then it will map it to the virtual machine and let the virtual machine write whatever it needs to it. So in this case, the VM kernel is optimizing the memory and is making sure that we are not using the memory in a bad way. We're not having a copy of the same memory on the physical RAM 5 times that is being used in read-only mode for no reason. So it's optimizing it here. It's giving you one portion. Use this for read-only, and when you need to make a modification, I'll give you a chunk. That's basically what it is. Now, it's good to know that page sharing is always active unless an administrator actually goes in and manually disables this function or functionality. Okay, now let's talk about ballooning. Do you guys remember how passionate I was about vMotion? Where I'm just as excited and passionate about the balloon driver or ballooning, simply because it is such a smart and intuitive idea that it just grabs you. It's like, wow, somebody actually really thought about that. So I'm going to try to explain what it is first, simply because I want you guys to just dig in and know what it is first, and then we'll cover some of the concepts and some of the basics. So what is ballooning? Let's say you have an ESX host over here. Let's call it ESX01. And ESX01 has a maximum of 4 gig of RAM. This has to do with memory optimization. And ESX01 has a lot of virtual machines running on it. Let's say it has 5, 6, 10, but let's take the example of 2. You have one virtual machine that has 1 gig of RAM and a second Windows 2000 virtual machine that has also 1 gig of RAM. Now, this first virtual machine is running on 512 meg. Everything is fine and dandy. And this virtual machine is actually running on fewer. It's running on 392 meg of RAM. Everything is cool. Everything is working fine for the operating system, blah, blah, blah. However, the host is running scarce. It's running low on memory for whatever reason. Maybe because a lot of virtual machines have been powered on with a lot of 1 gig. So you have 4 gigs of RAM here for ESX01, and you have 6 machines that you've assigned 1 gig of RAM to. So here you've over assigned the amount of physical RAM that you have for virtual machines, and as such you've put ESX01, the actual physical host, under memory stress, memory strain. So what does it do? It uses something called a balloon driver. What a balloon driver is, it's a device driver that's installed as part of VMware tools inside the guest operating system. So what it does is, let's assume the VM kernel decides that, okay, I need memory from somewhere. Let's use the balloon driver. So what the balloon driver does once it's initiated is it runs as a service or a device inside of the guest operating system, and it takes the unused memory from the operating system. So if this OS here is using 512 meg, it still has another 512 to go. Now, I'm not saying it's going to take the entire 512, but for the sake of the example here and to keep the numbers easy to follow, I'm going to say that the VM memctl driver, or the balloon driver, is going to take the 512 meg that are not being used by this virtual machine, since it's only using 512 and it's operating optimally. It's going to take the 512 that's not being used, and it's going to yield them to the VM kernel. It's going to basically tell the VM kernel, here, take this, use it until you need it. When you're done, let me know. So what happens here, and this is really cool, the VM is unaware of this driver. This driver doesn't affect it in any way, shape, or form. And the guest operating system is also not affected by the driver. It's done in such a smart way that this is just a simple device driver running inside of the guest OS. So as far as the guest operating system is concerned, this is a device driver for an application, for example, or a piece of hardware that is taking up 512 meg of RAM. It doesn't know, the guest operating system doesn't know that this driver is relinquishing this memory to the VM kernel, and the VM kernel in turn is reusing this relinquished memory to fill up or to use it to bring down the amount of memory that it needs to satisfy its scarce resources. So the memory that it's getting from here, it's using somewhere else to satisfy the resource need that it needs. It's going to do the same thing here. It's going to notice, the VM kernel is going to notice that, okay, VM02, for example, has a gig of RAM assigned to it, but it's only using 392. So in this case, it might go ahead again and take 512 meg of RAM from this virtual machine and use it somewhere else. This is called inflating the balloon. And it's just exactly the way it seems. If you bring up a task manager inside of the guest operating system, you're going to see that this operating system is running at a gig, for example. But it's still running optimally because all it needs for it to run properly is these 512 megs of RAM that were assigned to it in order for all the functions to work properly. So once the VM kernel doesn't need this memory anymore, let's say you turn off one of the virtual machines, it relinquishes this memory back to the virtual machine and deflates the balloon. Now somebody please tell me this is not cool. So you inflate the balloon when you need the memory. You grab the memory from the guest operating system of a VM that's not being used. You take it and you use it somewhere else based on the VM kernel's needs. And then when the VM kernel doesn't need this memory anymore, it deflates it and gives it back to the virtual machine. Now this is all done because when you create and configure a virtual machine, you're telling it, okay, we want to give this virtual machine 1 gig because you want to always be on the safe side and make sure that you always have more resources than you need for the virtual machine. But what you've done in fact is this 1 gig has now been grabbed by the physical virtual machine. So if you're adding more virtual machines and they're all coming up, you have a gig here that you've assigned to it but you're not really using. And this is where the balloon driver comes into play. It's taking this unused memory that you've assigned to this virtual machine, using it somewhere else, and then when it's done, it's relinquishing it back. A balloon driver is just flat out one of my favorite concepts with VMware and ESX. I mean, VMware has really thought this thing out, and the beauty of it is that it's using it as part of the operating system. So I mean, and it's letting the operating system tell it which memory pages to take. It's not forcing the operating system to relinquish the memory pages. It's telling the operating system, okay, here, you have a gig worth of RAM, you're using 512, I need 512 for this driver, and then it's taking it and it's using it for something else. This is really cool. Okay, now let's talk about swap. Now I'm sure most of you are familiar with the concept of a swap file or page file or whatever you want to call it. With the VM kernel, you also have a swap file for every virtual machine that you have. As soon as you power on the virtual machine, it's going to create a swap file, and this swap file is going to be located in the same place or in the same location as the VMDK file. And now the size of the swap file is determined by a small calculation here. Every VM might, and I say might because you don't have to, specify a minimum guarantee. So if you say that this, for example, if you say that the minimum guarantee memory for this virtual machine is 256 meg, for example, and the maximum it can use is 512, then your swap file is the difference between those two, which is obviously 256 meg. And yeah, don't tell me it's minus. Okay, I'll put the 512 on top. So the difference between the minimum and the maximum is the swap file size. Now the swap file should always be used, or should always be the last resort, and the reason being is that the system will perform poorly when it's swapping, as I'm sure you all have seen and noticed when you're paging in Windows or any other operating system. So again, the calculation here is between the minimum, the reserved amount for this virtual machine to function, which is 256 for example, and the maximum amount that this virtual machine can use, which is 512, ending up with a 256 meg for the swap file. What do you guys say if we now log into Virtual Center and see how we can monitor the CPU utilization, memory utilization, disk usage, network bandwidth utilization, etc., in order to give us signs of potential problems, if any? When monitoring your virtual infrastructure, it's extremely important to understand the difference between the tools that you can use to monitor the guest operating system and the tools that you need to use in order to monitor the actual virtual machine and the ESX host, because there's a difference between all three. The tools that you have that monitor the guest operating system are the traditional tools that come with Windows, for example, such as Perfmon or the Task Manager, that allow you to monitor what the operating system is measuring as far as CPU utilization and memory utilization, so on and so forth. Now, if you want to monitor the virtual machine and the ESX host utilization, you will need to use Virtual Center, and we're going to take a look at both. But with the new release of vSphere, now the VMware tools include a library called the perfmon.dll. So when you install VMware tools, it's going to install a file called perfmon.dll that plugs into Perfmon on the actual Windows box and extends its capabilities and features and gives you the ability to monitor, for example, the virtual CPU and the virtual memory and so on and so forth from a VM perspective. So now you no longer have to only manage the guest operating system's performance, you're also able to see what's going on with that virtual machine and the ESX host. And the reason I'm saying that is what looks to the guest operating system as 100% virtual CPU utilization is not the same as what is going on the ESX host, because the ESX host might be allocating 20% of the physical CPU to this guest operating system. So from the guest operating system's perspective, this 20% is 100% of virtual CPU. But from the physical ESX host perspective, that's 20%, because the physical CPU is divided and is serving up multiple virtual machines, whereas that guest operating system is only looking at the virtual hardware that it's installed on. So from the virtual hardware's perspective, that represents 20% utilization as far as the physical is concerned. So let's go ahead and go into a virtual machine and take a look at the Perfmon and also the Task Manager. So I'm going to go ahead and open the console of this virtual machine. And this is just your typical Windows operating system. Now you can always bring up the Task Manager if you wanted to take a look at a snapshot of what's going on as far as your virtual machine is concerned. And if you wanted more detail, you can always open Perfmon. And you can open Perfmon a number of different ways. I just like to use the run command, just type in Perfmon. And there you go. Now you'll get some performance monitors or performance counters that are there by default. If you wanted to add any more, you can always click on the plus button here, and you'll notice from the performance object drop-down that we now have several new libraries. So you have the VM memory and you have the VM processor. If you click on them, then it gives you more options as far as what type of counters you want to monitor. So now you have the ability to monitor the guest operating system, the virtual machine, and also the ESX host. That's from within the virtual machine's perspective. Now let's take a look at what Virtual Center offers us. So I'm going to go ahead and minimize this console here. Now, every object within the inventory has a performance tab, as you can see here. But for the purposes of this example, we're going to stick with this virtual machine. So I'm going to click on its Performance tab, and we're going to start off with the Overview view, which is the default view that you'll see when you click on that Performance tab. The Overview is kind of like a quick snapshot of what's going on from the CPU's perspective, the memory's perspective, the disk's perspective, the network perspective. So if you scroll down, you'll be able to take a look at these counters. And all the way down to the bottom, you'll notice that you have a day's worth of summary for ESX01. It's virtual machines, and you'll see the CPU, memory, etc., etc. So this is a quick snapshot of it. Now, if we scroll back up, let's start with what we have here to the left. You have two different views that you can choose from. This is the home view. Now, you also are provided with a storage view. So if you click on the storage view, you're going to get some cool graphics here that tell you what the space utilization is by file type, what the space utilization is by data store, so on and so forth. Up here to the right, you can always refresh. Now, if we go back to the home view, we also have the ability to specify the time range. So right now I'm looking at 1 day's worth of performance metrics gathering. So from the drop down, I can do real time to see what's going on right now. We can do a week's worth, a month's worth, a year's worth, and then you can do custom. So if this virtual infrastructure has been up for the last 2 years and you're trying to generate reports, you can always do custom and generate the reports based on the time slice that you want. Now, reports are always useful, and you can always tweak the reports depending on what you're trying to accomplish. So if you're trying to justify new hardware, you can always come in here and take a report based on the last 6 months that shows you're running out of resources. You could take that report and go to your management and say, this is why I'm asking for more hosts or more memory or more CPU power, because we've been running out of resources for the last 6 months. So I don't have the ability to grow this environment if the business has a need for more servers or applications at this point. So the performance metrics can be used to do a whole number of things, and you have all the information that you need from within Virtual Center. You can gather information about the host, the infrastructure, the clusters, and we'll take a look at different views, but right now we're just looking at this virtual machines view. So I'm gonna leave this at a day, and if we go over here to the right, you can see that you also have the ability to refresh the data if you needed to. Now, this is just an overview view. If you wanted to get more granular into what you can do as far as performance metrics are concerned, now you need to switch over to the advanced view. The advanced view gives you or allows you to dig deeper within every counter and take a look at what's going on. Now, you'll notice on the chart here, you have the ability to hover your mouse over a certain area of this chart, and it gives you what's going on at that particular instance, from the dates perspective, the memories, etc. So you can change the view that you're trying to look at here. Right now, I have it set to disk. You can always, from the drop-down menu, set it to CPU. Now, these are the counters that it's monitoring by default from a CPU perspective. And we'll talk in a second on how you can modify these counters, whether you want to add or remove some of these counters. But let's take a look a little bit up here to the right. We already covered what you can do with as far as the view is concerned. We're looking at CPU, but you can also look at disk, memory, network, system, etc. You can always print this particular chart if you wanted to. Refresh the data again. You can save it. If you wanted to save a JPEG image of this chart, you can always use that to save. Or if you wanted to have multiple virtual machines, if you're trying to monitor different counters or different virtual machines counters and you wanted to cascade them or you wanted to tile them, you can always tear this view on its own window and then move it wherever you want on the screen. And this is useful again if you're trying to monitor more than one counter at the same time, or if you're trying to monitor more than one counter from a different virtual machine, so you can set them next to each other and you're able to take a look at them in a more comfortable way. So I'm going to go ahead and close that. And now let's go into the chart options here. Once you go into the chart options, we're looking at the default chart. And you'll look here, you'll see that I'm looking at memory. So for example, if you wanted to change the types of counters that you're looking at from a memory perspective, first of all, you have to specify the time slice. You can look at them from a real-time perspective, or if you want to look at them from the past day, etc., you can select that. But if you're looking at them from a real-time perspective, you can come down here and then select the counters that you want to look at. So if you wanted to look at the memory swap, you wanted to look at the balloon, for example, you can always select that, click OK, and it's going to add it to the graph, and you'll be able to see what's going on from a memory ballooning perspective. So on and so forth. You have the same thing for the network, for the disk, for the CPU, for the system, etc., etc. Now, you also have the ability, some people don't like to see the line graph. You want to see more of the stacked graph. You can always switch your view here, and you'll notice you'll have the bars that are going up and down next to each other rather than have the lines going across the screen. So this all depends on how comfortable you are of reading the different types of graphs. Some people like the lines, some people like the stacked graphs. I'm going to keep this back at the line here. We're going to click on apply. You also have the ability of modifying the chart settings. So if you come in here and modify the chart settings to your liking and you want to save it, you can always click on save, and I'm just going to name this one Eli for the purposes of this example. And now from the drop down menu, every time you come in here, you can switch between the default and Eli. And if you obviously wanted to delete something or manage it, you can always select it, click on delete, and boom, that is gone. So this is from the virtual machines perspective, how you can monitor things. Now let's take a look at what we can do from the actual host perspective. Now you'll notice navigating all the screens is always the same, but let's take a look at what's going on with ESX01. Let's click on the Performance tab. And this gives you an idea of what's going on this particular host. Again, you have the same options here that you can select from, so we're not going to dig deep into these. But let's also take a look at some of the cluster performance metrics that we can see. So once you select the cluster, again, we can go to the Performance tab. And now you have an idea of what's going on across your cluster, across all the ESX hosts within your cluster. Or if you wanted to look at the resource pools and virtual machines, you have the option of doing that from the view here. And voila, this gives you all sorts of cool graphs that you can take a look at. You can also select the hosts themselves. So this gives you an idea of what's going on across all your hosts in this cluster. And you can obviously also go up to the data center, select the data center, go into performance, and then, the higher you go up in the inventory, the more you're going to see from a general perspective what's going on across your data center. And again, from the views here, now you're looking at the clusters view. So this is just different ways that you can look at the different metrics and information that you have within Virtual Center. So you can, if you want to take a look at storage within the data center, this gives you an opportunity to do that, and so on and so forth. Performance metrics are just fantastic because it justifies a lot of things, allow you to take it to management and say, hey, I'm not just asking for more toys here, I really need to be able to scale the environment because you're going to come to me tomorrow and ask for a certain servers for applications or a business need, and I'm not going to be able to satisfy that, and here's the proof. So performance metrics, especially for Virtual Center, you're able to run a lot of cool reports to be able to justify what you're asking for. Now, monitoring an environment is great, but you can't be monitoring an environment all day. You can't have these cool charts in front of you all day and that's all you do is you're looking at events and you're monitoring all day, because you have other duties and you have other tasks that your job entails. So how do you automate the monitoring of your virtual infrastructure so you can get notified when something happens? Well, you use that by leveraging alarms. Alarms are a way to notify you when an event or a condition has been triggered. And we're going to talk about the difference between an event and a condition in a second. But every object in the inventory also has an alarms tab. The same way every object in the inventory has a performance tab, every object in the inventory has an alarms tab. So if we go into alarms, you'll notice that we have two types of views. The first view is triggered alarms. Now, what triggered alarms means is that whenever an alarm is triggered, it's self-explanatory, it's going to show up in this list here. Now, obviously, I don't have any alarms that have been triggered, but if I did, they show up in this list. Now, once they show up in this list, you can leave them alone, which means they're going to continue to bother you. Or once you understand that, okay, I have an alarm that's been triggered, you can come in here and acknowledge that alarm so that it doesn't have to repeatedly notify you that there's something going on. And then there's the definitions view. And this gives you a list of all of the default alarms that are available that have been created for you. Now, if for whatever reason these alarms don't meet or don't satisfy your need, you can always right-click anywhere and go to New Alarm, which brings up the New Alarm wizard that allows you to configure the alarm. But before we do that, let's talk about the different types of alarms that exist. So you have what's known as an event alarm. So you're monitoring an event. So an event can be, for example, there are insufficient licenses, or it can be that the health of a host's hardware has changed, or you've change the configuration of a distributed virtual port group. That's an event. You can get notified based on that. Now a condition means that a virtual machine CPU has changed. It's gone over a threshold that you've specified. If a virtual machine CPU has gone over 90% and you want it to get notified when that happens, then you can configure an alarm for that. So there's two types of alarms. There's an event alarm and there's a condition alarm, and you can configure those accordingly. Now if you wanted to configure an alarm, custom alarm, we can come into this wizard here, and the first thing you're going to notice is you obviously have to give this alarm a name and a description so you understand what you're trying to monitor, and then you want to tell it, well, what are you trying to monitor? Are we trying to create an alarm for virtual machines, or are we trying to create an alarm for hosts? And you have a whole slew of things that you can select from here. I'm going to stick with virtual machines for the purposes of this example, and here you have the ability to tell it what type of alarm you want to create. Again, you can create alarms based on conditions, like I said, or you can create alarms based on events. So what type of alarms are you trying to configure? And then if you wanted to create the alarm but you didn't want to enable it right away, you can obviously uncheck this box. Now let's go into the triggers box and actually configure what do you want this alarm to trigger against. What do you want to happen in order for this alarm to get triggered? And from the button here where it says add, you can add the first trigger, and then you'll notice that it's VM CPU usage. So if you want to monitor that, you can always select something else from the drop down, whatever else you are trying to monitor, and then you can modify the condition here. So if you want it to be above, for example, or if you want it to be below. So in this case, we're saying I want you to trigger once it's above 75%. I want you to send me a warning, and if it lasts for 5 minutes, then I want you to send me another warning or another alert at 90% if it lasts for 5 minutes. So I don't want it to send me an alert just because the CPU spiked to 75% for a few seconds or for a minute. But if the CPU is sustained at 75% for 5 minutes, then alert me. The same thing, if the CPU is sustained at 90%, then alert me. So you're giving it what you want here as far as the triggers. Now you can always add additional lines and then set the triggers or set the different alarms here. And from this radio button here, you're able to tell it, I want you to trigger if any of these conditions are satisfied, or I want you to only trigger if all of them are satisfied. So if you want to say, for example, I want the CPU utilization to be at 75% and the memory at 75%. So if both of those are met, then send me alarm. But if one of them is met and the other one is not, then don't send me alarm. This would be the place to configure that. Now from a reporting perspective, you have two options. If you wanted to specify a range, for example, the first option is repeat triggered alarm when condition exceeds the range, this range. So let's say you have the CPU utilization at 75%. You want it to send you that alarm again if you set it here to 20%. So let's say 75% CPU utilization. If add another 20% on top of that, now you have 90%. So send me another alarm or another alert when the CPU utilization reaches 90%. So this is where you can configure a range here of how often you want it to send you and at what intervals. Now the frequency, how often do you want me to send you this? So if you set it here to, let's say, 5 minutes, then it won't send you this alert every 1 or 2 or 3 minutes. It'll send you this alert every 5 minutes. So every 5 minutes is going to check if those metrics, if that trigger, if that state is still within those triggers, then it's going to resend you the alarm and so on and so forth. But it won't send you the alarm if you don't want it to every 5 minutes or every 2 minutes. You can configure this interval based on what you want in order to not overload your monitoring system or your email with constant triggers about this alarm. Now, what do you want it to do? So you've configured a trigger. I want you to send me an alarm when my CPU utilization hits 75%, and another warning or another alert when it hits 90%. But what actions do you want me to do when these events or conditions are met? This is where you can come in and add 1 or 2 or 3 reactions to the trigger. So the first thing I want you to do is send an email notification, and you can tell it the frequency. You want it to send an email notification once, for example, or you want it to repeat. So this is where you would be able to control it. And you're able to control it when it goes, for example, here, you'll see that it has icons. When it's going from warning to alert, you want it to send the email once or multiple times. If it's going from alert back to warning, from alert or from warning back to normal, from normal to warning. So you're able to control when do you want this email to be sent, and based on what type of criticality, send once, twice, or continue to send. Now, this is the first option, allows you to send an email. Now, you can select the second option here. From the drop-down menu, you can send a notification trap. You can run a command. There's different things that you can run against the virtual machine once that trigger occurs. You can power on the virtual machine, power off the virtual machine. You can suspend it. You can migrate it, which is awesome, because if the CPU utilization hits 75% for a good 20 minutes, then initiate a migration of that virtual machine from ESX01 to another ESX host that might have more resources available for that virtual machine, and so that it's not constrained for resources. If the problem is the underlying ESX host, the problem might be the virtual machine. At that point, you have to give it more resources. But this is one of an automated responses that you can use just in case it's the actual host. So you can take that measure against it, and if the alarm persists, then you know that, okay, you have it automatically set to migrate, so it's already migrated, and this alarm is persisting, which means it's not the ESX host. The problem is the actual virtual machine doesn't have enough resources to satisfy its needs. So on and so forth. You can always scroll down through this here. And once you're ready, you can also click on OK and create the alarm. So I'm going to click on cancel here to exit out. Now, in order to configure Virtual Center to send you an email once a notification has been identified, you have to configure that. And to do that, let's go back into the home screen. From the home screen, we're going to go to Virtual Center Server Settings, and then we're going to click on SNMP. This is where you can configure all of the host traps in order to send the SNMP stuff from the alarms. The mail allows you to specify the SMTP server and the sender's account, so where do you want it to send from. This allows you to configure how you want these alarms to deliver the notification to you, whether it's mail or SNMP traps, so on and so forth. So you want to make sure these are properly configured in the environment in order for these alarms to reach the appropriate system or the appropriate person for that matter. And that's it for alarms. It's very basic, very straightforward. Alarms are extremely useful. As the environment grows, you're going to see that you rely on alarms more and more in order to allow you to know what's going on in the environment, because like I said, there's no way you can sit there and constantly monitor all of your virtual machines. So you rely on alarms to notify you in the event that certain triggers are met. And that's a wrap for this module, folks. We hope it's been informative for you, and we'd like to thank you for viewing.